Now for question 4, we're going to do just a simple question, Boolean function precedence. So given the Boolean function f x y z equals not of x implies not of y implies z, what direction takes precedence when there are two imply operators? Traditionally they go from left to right, but for the implies operators when there are two, it actually goes from right to left. So you do not y implies z first, and then you do not of x implies the result of this. So let's just see. Not of x implies, not of y implies z is actually, you can see this as not of x implies bracket not y implies z. So you can assume there's a bracket there when you have two implies. You do what's inside the bracket first, and then you do the result. So 0 implies 0. Actually, this is a not. So it's 1 implies 0, or if you like, true implies false, which is false. And then not of x, which is 1, or true if you feel like it. True implies false is false, so the output's going to be 0. So let's do it again. Not of y is 1. 1 implies 0 is false, so 0. Then not of x is 1. 1 implies 0 is 0. So next question. Not of y implies z. So 1. 1 implies 1 is 1. It's true. Not of x is 1. 1 implies 1 is true. So 1. Not of y, 0. 0 implies 0 is true, because anything from 0 is true. Not of x, 1 implies 1 is true. So this is the one you might be confused by. So not of y, so this makes this y 0. 0 implies 0 is always true. Anything from 0 implies anything is going to be true. So think of it as false implies false is true. Not of x is true. True implies true is true. Not of y, 0. It's more, 0 implying anything is going to be true. Not of x, 1. 1 implies 0. Or 1 implies 1 is true. 1. And draw this out just in case you didn't see. So 0. 1, 0. So not of y. So this is x, y, z. So not of y implies z. So that's going to be not of y, 1 goes down to 0 implies 0. This can also be seen as false implies false, which, as we saw in previous lessons, is always true. So it's going to have a 1 as an output. That's going to be 1 as an output. Now we take the next value, not of x, so x is 0. So it's going to be 0. Not of x is going to be 1. 1 implies 1 is 1. So again, not of y gives you 0. 0 implies 0 is 1. Anything from false implies false is going to be true. Not of x is 1. 1 implies 1 is 1. Or true implies true is true. So let's move on to the next question. Not of y is 1 implies 0 is false. 1 second. Yes, so not of y is 1. 1 implies 0 is false. Not of x, so this 1 goes to 0. 0 implying 0 is going to be 1. Now you can actually see, because we're doing the not of x last, and x is 1, these will all go to 0. And whenever 0 implies anything, no matter what this result is, no matter what the result of not of y implies z is, because this is always going to be 0 in these hearts, you're always going to get true. So this will always be false implies whatever, which will always be true for these final 4 bits. So you only really have to do the calculations for the first 4 parts. And this is your final outcome, 0, 1, 1, 1, 1, 1, 1, 1. That is a result of this function. That is it for lab 2. So to recap, we went over some BDD theory to start with. We then went on to probably the most difficult question, the Boolean function, trying to get the Boolean function from a truth table to work backwards. One thing to note was we asked to use disjunctive normal form. Now, if we didn't ask to use disjunctive normal form or conjunctive normal form, you could actually look for patterns within the output. So if you see here, the output is 0, 1, 1, 0 for the second 4 bits. Does anyone recognize this output? It's the exclusive OR output, but of which inputs gives you this exclusive OR for the second 4 bits? I will leave that to you to figure out. So if you didn't have to use disjunctive normal forms, so the AND conjunctive clause is connected by disjunctive operators, you could actually find that there's an XOR feature in the output, and you could actually have a different Boolean function that gets you the same result. That's just one thing to notice. So you can look to the output and look for features that you've seen before. See, is there a different way of creating these functions? Yeah. Then we had to build these BDDs using different orders and to see how it affects the BDDs and how their efficiency can change and which way you can determine which is the best ordering. Often the clauses will actually tell you which way will be the best way to order. And then we just showed how we can combine 2 functions together to a very simple example, and then how we can build this into classifiers and connect them using the Boolean operators in Synco, or in the ADD-lib rather. And then finally the Boolean function precedence and how to, which direction to do questions like these in what order. You have 2 implies, you go from right to left, put a bracket around these, and then work from there. And that's it for lab 2. The next release, I believe, will be the project. So what you've learned in lab 1 and lab 2 should be sufficient to complete the project questions. Thank you.